So hi everyone, thanks for joining the first global meetup on Feature Stores. I'm Natalia, I'm the event organizer for the meetups. I'll say some things before we start. So this meetup is being recorded and you can rewatch it later or share with others who might find it interesting. Unfortunately, Airbnb has some last minute hiccups, so they had to pull out of this presentation today. But they will be coming up in then future meetups that we have planned for next year. On the bright side is that we're going to have a little more time for each of the presentations we have today and perhaps a longer Q&A. And now we'll pass to Davor and he'll kick off this meetup.
All right, thank you, Natalia. Let me share my screen over here for a second. All right.
Right.
All right, I think we can all see this. Thank you, Natalia. Let's get started. So welcome everyone to our first global feature store meetup. My name is Davor Bonaci. I'm the CEO at Kaskada, and I'm one of the organizers today together with Jim, who will introduce himself in a moment. Given that this is our very first meetup, I want to take a moment to introduce what this is all about. We, the organizers, want to provide a vendor-neutral, safe space for data scientists, data engineers, ML engineers, and others to discuss the feature store space. Keywords here are truly vendor-neutral and safe. Vendor-neutral means for me that you'll see different perspectives presented. The different approaches will be presented at the same time, that you'll be able to compare them, that you'll be able to ask questions of this group and hear different opinions. And while vendor neutral does mean that we won't have any blatant product pitches here, obviously there are products underneath many of the presentations. That part I think makes it stronger because it's not theoretical, you can actually try it yourself. Safe space also means that everyone is welcome. I'm glad you are here with us today, regardless of where you work, regardless of gender or any other characteristics of any kind. Maybe most importantly, this is a tech meetup. So I want to be explicit. You are welcome here regardless of your prior experience, whether you are new to the field in general or have been lurking around, whether you've built systems in the past or been using them. Just know how welcome you are here regardless of any of that. And finally, I want to introduce featurestore.org. This is a tech community interested in sharing information and knowledge about the feature store space. We have featurestore.org website, this meetup group, the Medium page, the newsletter that you can subscribe to. Please check out all of those resources, as time permits. So, while we are the organizers of the featurestore.org, from here, I want to hand it over to Jim, another organizer who will share a little bit about history, give credit of how this all started, and Jim, please take it away from here.
Okay, thanks, Davor. So yeah, my name is Jim Dowling. I'm CEO of Logical Clocks. I'm also an associate professor at KTH. And featurestore.org actually came about from a couple of PhD students in our group, Alex Ormenison and Mahmoud Ismail. And they were doing research on feature stores, and they said we should put up a single place where we have lots of information about the existing feature stores that many hyperscale AI companies had written about and they talked about. So basically it was kind of a homegrown page with, I don't know, maybe 25 different feature stores, talks from different feature stores, primarily videos. And it's been a space that has evolved primarily through industry rather than academia. And so they started the page, but they realized that, when we were getting hundreds of hits on the web page per day, and I think at some stage it was shared on Twitter, and they realized that this was getting too big. So we at Logical Clock said we would help out, and then we reached out to others in the community. And with Davor, we decided we'd start an organization. So we're just bootstrapping this organization, but the question mark in the middle means basically it's an open organization. So if you want to organize an event, if you want to talk at the event, there is a link to submit a proposal for a talk. If you want to write about feature stores, we have the Medium publication where we'd like people to submit publications. We want to create an ecosystem where we can learn together about feature stores. And we want to learn about the techniques that we use to build feature stores, how we use them, and the value that we can generate from them. So this is an open organization, and we'd like to welcome more and more people in to help drive it. It's a community-driven platform to spread information about feature stores. So today's meetup, as Natalia mentioned, Airbnb had to cancel at the last minute, and they will come at a future meetup, but I'll kick it off. I'll talk about HopsWorks Feature Store, and HopsWorks Feature Store was actually the first open source feature store to be released at the end of 2018. And I'm calling it HopsWorks 2.0 because we redesigned the APIs. So we'll talk a bit about what we've learned in that period of time and the new APIs that we've incorporated in our architecture and platform. HopsWorks is an open source feature store. Davor will talk about bridging the gap between training and production with feature stores. And we'll conclude with a Q&A. And we'll see. So if you have some questions, take them. We can take them obviously at the end of the talks, and we can take them at the end as well. And if you have questions about the meetup in particular, the format of the meetup, we'll leave them until the Q&A at the end. Okay. So there is an upcoming meetup after this. We have already 2 talks, and we're really excited to have one of the tech lead at Michelangelo Feature Store, Atindrio Sanyal, who's going to talk about the feature store as part of Uber, called Michelangelo. And then we also have Monty Swaben, who's the CEO at Splice Machine, who will talk about their feature store. And that meetup we hope will come at some stage early mid-January. And if, again, just to repeat, if you would like to talk at an upcoming feature store meetup, please fill in on the web page and reach out to us, and we'll for sure we can accommodate you. Okay.
All right, with that, I think Jim will go into his presentation on HopsWorks 2.0. So Jim, take it away.
Thanks, Davor. All right. So let's have a look. Okay. So HopsWorks, it's an open source feature store. It's built primarily by logical clocks, but we have a background in research, and the platform was built originally as open source. It's still available as open source, but there is also a managed version of it that I'll show you later on. Now, the feature store as a space has, I would say, it has become a key part of the platforms that you need to put AI models in production. There is now consensus on many of the platforms you need to take your data and turn it into models and run them in production. And this, many of you will have seen this diagram and are so bored of it because you've seen it from Google. Scully, about 3 years ago, he released this first. It basically shows that training models is only a small box in the middle of our screen here. It's this little box here. And that's only a small part of putting models in production. Many of you know that this is problematic. But what I'll claim here is that we have reached some sort of consensus on how we manage this complexity of putting models in production. And there's 2 main parts. There's the feature store, feature engineering, which is managing the data for your models. And then we have the machine learning platforms that are used to train models, also to engineer features. But we present the insights we've learned. So if we start out here and we look at an end-to-end machine learning pipeline with the feature store, what we can see is that if we start up here, we have our data up here. So this is our enterprise data, and we have feature engineering. We need to take that data and turn it into features. So that feature engineering happens before the feature store primarily. You want to have ready-to-use features in the feature store, and those features can be used primarily by 2 downstream clients. One are the data scientists who are going to train models, but also batch applications that need features to score them in offline. And then we also have models that run in production, and those models need to go to the feature store to retrieve feature values, to build feature vectors, to make predictions. Okay, I'm just going to check the chat here if anybody had anything about the okay. No, it's just about questions. All right, so in the middle, we can see we have this part here, which is just model training. And we need to train models, obviously, on features. And those models we typically would store in a model registry or repository. And then we can use those models in batch applications, or we can serve them over the network to online applications. Now, this is a pretty standard picture that many people have seen, but there's a little bit more to it, and in particular with the feature store. So I'll start with the feature store. We also have to monitor models that run in production. And monitoring them basically means comparing the live traffic that comes in. This is one of the ways we monitor them. The live traffic that's coming into the models, compare that with the distribution of data that we train the model on. So the feature store typically will store statistics about the training data for the models. So we can go to the feature store, we can retrieve the statistics for the training data that we use to train the model and compare it with the live traffic, where we compute statistics over that live traffic and see if there's been divergence, or what we call data drift, in the live traffic going to the model. So the feature store can be used for that. The feature store can also be used to log predictions that are made on the models, so that we have those predictions available later, that we can add outcomes. If outcomes arrive later, we can add the outcomes again to the feature store. And now we have new training data that we can use to train new models, because we have the outcomes and we have the predictions. That's new supervised samples for machine learning. And the other place that we have to think about is that when we do feature engineering and when we train models, often we split them up into two different parts. So the feature engineering is a pipeline that feeds the feature store here. And then we have a separate training pipeline, which takes the features from the feature store and it trains models. And typically you would need some platform that manages experiments for you, so that you can run many hyperparameter tuning experiments, that you can train models with lots of GPUs, that you can obviously then inspect the performance of the training that you're doing. So visualizing the loss functions, being able to debug your models effectively, and so on. Now, there's slightly more to it than just this. This is kind of the complete picture that many people would see today. The next step that I'll introduce, and this is something that we're working on a lot of at Hopsworks, is that we like to have visibility of the entire pipeline end to end. So you do need to, at some level, collect metadata of all of these stages. And we see this in platforms like TFX, TensorFlow Extended, and MLflow. And in Hopsworks, we use something called implicit provenance. We had a talk at Usenix OpML about this. You can read more on it there. But basically, if you collect enough metadata about all of these steps, you're able to debug end to end. So when you have problems in models in production, go all the way back to the feature store and even further back to find the root cause of any problems. Governance, being able to say who did what and who authorized what along the pipeline, and also reproducibility. So if you have a model that's running, be able to recreate the training data set, for example, for that model. Okay, so our feature store is built on some very simple concepts. We have the concept of features themselves, but the features we organize into groups, logical groups, because typically you won't ingest one feature. You won't have a pipeline which computes a single feature. You'll have a program or a pipeline that computes a bunch of features from the same data source. Maybe it's a data warehouse, maybe it's a data lake, and maybe it's updated. Those feature values are updated once per day, for example. So you update it once per day. And maybe the other feature group that we have here, it comes from a different data source, maybe a data lake, and maybe it's updated once a week or once a month or once an hour. So we introduce feature groups as a way of logically grouping features together and also providing scope, because if you have many features called name and you don't know the scope they belong to, then it becomes quite hard to disambiguate them. Now, that's the basic feature store. You have features and groups of features. Data scientists can take these features and reuse them in training data sets. And this is the key property of reuse of features in a feature store. So if you have a feature store and you want to go there to find features to train models with, well, if you want to reuse them, what we basically provide is the ability to join these features together. that you can basically say, I need these features and I'd like to put them together into this training data set. So when we say training data set, we mean training and test data, not just the training data, of course. And this training test data set, obviously it's labeled because we're looking at supervised machine learning in particular. And that training data set, you can obviously work with as a data frame in our platform, but you can also serialize it and materialize it to disk. So you might say, I want it in a particular file format like TF record for TensorFlow or NumPy for PyTorch or CSV or Petastorm or so on. And you might say, I want to store this in a bucket in S3 or on an Azure blob storage container or in HopsFS or some other file system. And everything here should be versioned for reproducibility. So they're the three abstractions, the features, the feature groups, and the training data sets. And how we get the features into the feature store is basically that we have these on the left-hand side here, we can see our sources of data. And we have some of them that are updated very frequently. Some of them are updated less frequently, but still quite frequently that you probably need a streaming application to update the feature store. And then we have batch applications that are maybe updated hourly or daily or weekly. And they might involve even larger volumes of data. So one of the properties of the feature store is that obviously these feature groups are coming from these different data sources and they're being updated at different rates or cadences. But the downstream users of the feature store, so the online applications that need to go to the feature store to retrieve their features, to build their feature vectors, they need low latency access, so millisecond access to retrieve these features. And then when we want to train models with large volumes of features, or we want to score large volumes of features in batch applications, we may need to scale to terabytes or even larger. So typically the feature store consists of two databases. We call it a dual database setup. We have an online feature store and an offline feature store. And there's many different databases that are used out there. You see databases such as Cassandra, Redis, you see DynamoDB. We're using a database called NDB or MySQL cluster as our online store, MySQL cluster. And the inventor of it, his name is Mikael Ronström. He's actually working at LogicalClocks. So this is a database we developed. And the other database we use is called Apache Hive. And in fact, both of these databases share a single metadata layer. So we have a metadata layer which pulls these two together. We'll just use a big M for that. And the data for Apache Hive is stored on our file system called HopsFS, which ultimately is stored on S3 in AWS or in Azure Blob Storage. Okay, so this is kind of how our particular file, our feature store works, that you have these pipelines. The pipelines can be run inside our platform or outside. We're very open. You can run them on Databricks or any Python or Scala environment. But you can see it's quite complex. One of the problems is that you might want to write some features to both the online feature store and the offline feature store. And if you as a developer have to write pipelines that ensure consistency of features between both online and offline, that becomes quite challenging. So what we do is we introduce abstractions to make this easier for developers to work with. So what we did, and I think we were first to do this, was introduce the data frame API as a general purpose API to the feature store. And this data frame can be a Spark data frame or it can be a Pandas data frame. So you can write your feature engineering pipeline in Pandas and Python, or you can write it in Spark, so PySpark or Scala Spark. And what you do is you basically ingest a data frame into the feature store, and then you indicate for every feature group, is this feature group online or offline or both? So this one might be just offline, and another one might be online. And the pipelines are basically programs that push data frames into the feature store into feature groups. So now the developer only has to worry about feature groups and data frames and not worry about pushing to different databases. The one aspect of feature stores that sometimes gets overlooked is real-time feature engineering. So if you, for example, have to engineer features that arrive in your application, so you have data arriving in, for example, on a web page, you might have a form with 50 different fields to fill in, and you need to engineer features from them in less than a second or two. Often you won't have enough time in your feature pipelines to engineer those features, push them to the feature store, and then retrieve them. So you might need to do that in a dedicated real-time feature engineering layer. So we have a framework called HOF that we talked about at the last Spark Summit. You can read up more about it. But it basically is giving you scalable feature engineering using PySpark. at the back end. So let's have a look at some code, because this is all very high level, and we'll look at it in a second. So firstly, we have in our first version of the feature store, we had this general purpose data frame API. We introduced the feature store as a cache for these features. So it wasn't a library. So originally when feature stores came out, there was a debate about whether feature store should be really about just versioning the feature pipelines and not about storing the data. So I think most feature stores now cache the data, but there are some that still go for the library approach. We have then the two parts of the feature store, the online part, which is low latency database for providing features to serving features to online applications, and then the offline feature store, which is scalable, which stores also version features. The online feature store will only store the latest values of features, but the offline will also store the version features. And I'll talk about that in a minute. And then finally, we believe features should be reused, and reuse means joins. So if you're not joining features together to create trained data sets, well, then you're creating a pipeline for every trained data set. So that means a new pipeline, which means that the number of pipelines will grow linearly with the number of models you put in production. So we want to avoid that by reusing features, and that's where joins come in. So what did we learn? Well, we learned from our first version that we tried to hide the feature group abstraction and just present a flat namespace of features. And honestly, it didn't work. And one of the reasons it didn't work was, apart from the fact that you would get clashes in the names of features across feature groups, but also we had to come up with a way of supporting versioning of feature groups, because the schema of the feature group may change over time. Not just that you drop a column or drop a feature or you add features, but also you may change the implementation of a feature. You might have a feature such as an embedding, and you decide, I need a new way to compute this embedding. The type of the embedding is the same, but the way you compute it is different. So logically, you need a new feature, a new version of the feature to represent it, because you can't mix the old version with the new version. That you can't train models with mixed implementations of an embedding. So the other thing that we looked at was data versioning. So we'll talk about that in the middle, or what is commonly known as time travel. Another part was the MLOps aspect. So if you have a development feature store and you have a staging feature store and a production feature store, how do we move our features from one to the other? So what we introduced was better support for multiple feature stores, development, staging, and prod, and we have the join features across those. Support for better support for complex joins of features, time travel, I've mentioned already, and then simplifying our libraries, because we had different libraries for Python and Spark clients, which led to some confusion in the community. So simplifying to a single library called HSFS net. So this is HSFS code, and we can see some simple code here. We have, this is a Spark client, and you can also have Python clients. We're reading up some data from a bucket in S3 into a data frame. And then we do some data engineering or feature engineering of the data frame. And after that, we're going to create the feature group. And this version is the schema version for it, not the data version. It's not like a log of the data, a commit version of the data in the feature group. It's the actual schema. So version 2 would be a new version of the schema for this feature group. And then we have a description of the feature group, and then we have a primary key. So the primary key is often called an entity ID in other feature stores. But we use the term primary key because it's more general. You can have multi-part primary keys. There's no connotation that this is a single key, but you may have multiple parts. And here we have 2 parts in our primary key. And then we basically indicate that this particular feature group will be written to both online and offline. So the data frame that we read up from the bucket in S3 earlier and did some feature engineering on, we can save into that feature group. And we can also tag it to make the feature group easier to find and the features in it easier to discover if I use it. Okay, so if I'm a data scientist, so that's it. Often data engineers and data scientists write those pipelines to ingest the features. Data scientists, what they can do is they can basically join features together. And here we can see we have a data frame that we get by joining all of the features from the first feature group, the second feature group, the third feature group. So we're joining features from rain, temperature, and location. We're trying to get a bigger data set for predicting rainfall at a location. There is a query planner which will try and find the common join key between the feature groups. It looks at the primary keys for common overlapping primary keys, and it's the largest overlapping set of primary keys. You can override that if you want to and explicitly say how to join them. But once we get back this data frame with our training data, we can basically save that to disk. So what we're doing here is we're basically creating a training data object, and we're saying the training data will be stored in this bucket in S3. It's going to be TF record data, and we're going to split the data into 70% training, 20% test, and 10% validation data. It'll generate a random split of the data. So we can just save it here. And in this case, it's going to run a Spark job to actually materialize that data frame, to join the data frames together, representing the feature groups. And then it will save that to the bucket in S3. After you've done that, you can have a notebook to read up the data. And in TensorFlow, you can just read up a data set, a tensor data set directly by just calling td.read, and then the name of the split you want, train, test, or validate, which is quite nice from a data science perspective. So from a data scientist, you get a lot of flexibility here. If you want to change your split of your data, it's just a small change. If you want to change the file format, it's a small change, rerun this. You know, if you want to change your training data set, again, small changes in the join, you know, maybe not selecting a particular feature or just selecting a subset of features. So you get a lot of flexibility here in creating your training data. And as we know, that's one of the big challenges of data science is creating training data takes a lot of time. So let's have a look at some of the new features, which we think are kind of interesting for the community. If I have a feature group here and I insert a data frame, that means I'm either updating or appending to it. We call that an upsert. And we'll get a new commit. And that commit will have a timestamp, and the data will be related. The data frame that we ingested for this feature group will be related to this commit and timestamp. So we can get the details of all the commits on a feature group. We can see it's like a Git log, right? You're seeing all the commits on it. We can also have multiple versions of the feature group. Here we can see we have version 1 and version 2. And we can say, I would like to get a data frame for version 1. And the good thing about this is that when you have production pipelines working with version 1, and somebody wants to change a feature group, maybe drop a column, maybe change the implementation of a column that's an embedding, then they create a new version of the feature group. And they'll need to then backfill that new feature group with data, and then they can use it, and you can work on that in parallel with the existing feature group version 1, which will continue to work, and the pipeline will continue to work. So the next one you can do, this is classic time travel. So you can actually, you can go back in time and say, I would like to get a data frame representing this feature group as of this point in time. You can see here we have a timestamp, which is related to this commit ID. And in fact, underneath this, the implementation of this is using a framework called Apache Hoodie. And we're also going to add support for Databricks Delta. So you'll be able to choose whether you want to have Delta or Hoodie as the engine here. But both of these file formats support time travel. The trade-off you get, you say nothing comes for free. So every time you do an update, we're going to store a bit more data. So we're going to store, if you update an existing, it's Parquet data underneath the hood here. So if you update an existing partition in Parquet, we're going to store a copy of that Parquet file. And then over time, if you do many updates to your feature group, there'll be more data stored, and the cost will be increased storage, but you get this time travel capability. With Hoodie, it's quite easy to clean up and say, well, I only want to store the last 3 months or 6 months of commits, and then it'll compact and remove the data from before that. The other capability that both Hoodie and Delta have, and we expose here as read changes, is to get the interval. So give me all of the data that arrived in a particular interval. You can see here we have the start interval, and then we have the end interval here, and that will retrieve the data that arrived within this time frame. And this is useful if you're a data scientist. You might say, hey, I'd like to have the years 2010 to 2018 as training data, and then 2019 to 2020 as test data. And then it's quite easy to then get the data for those two and train your models with it. So I have, I think, a couple of minutes. So I'll do a quick, very brief demo just to show you what this looks like as a platform. So if you want to try it out, you can go to hopsearch.ai, and it's a managed platform available on AWS or on Azure, and you get a bunch of free credits to get started. And if you log in, you'll need to, there's a demo cluster you can just kick the tires on and try it out. But if you want to do anything proper, you'll need to set up, connect it to your AWS or Azure account. And once you've done that, and you need to create a cross-account role in AWS, you can create clusters. So you can just create clusters here. And the clusters themselves, you can scale them up and down. So you can add workers, remove workers. do feature engineering on them. You can also do training, but primarily people are doing feature engineering. You can do backups, stop the cluster if you're not using it. So you only pay for the compute that you're using and the storage that you're using. So so let me have a quick show you the platform. This is HopSearch once you log in. We have this thing called projects over here. So I created a feature store tour here, and you can click this button to create it. And I'm just going to go into it to show you briefly where the feature store is. So we have a bunch of other services on the left-hand side, but I'll highlight the feature store here. You know, you can do feature engineering here. So we have jobs and Jupyter notebooks for that, and Python libraries you can install. But if we look at the feature store here, we can see we have the three abstractions we talked about earlier: the feature groups, the training data sets, and the features themselves. We have connectors to connect to external data sources. So, you know, Redshift or Snowflake or wherever your data resides, or S3. And in this feature store, we have 113 features. We have 11 feature groups and 4 training data sets. And we store, so when you ingest your data, we'll automatically, or by default, I should say, compute statistics over them. So if we take a given feature group here, and we look at it, it's a cached feature group. You also have on-demand and online ones. We can look briefly at statistics that we pre-compute. So when we ingest the data, we compute these statistics. We're using a library called DQ for this. And we also pre-compute correlation matrices over the features in any given feature group. So you can do some exploratory data analysis by looking at statistics of features. You can preview data, and you can do all of this from your notebook, right? So you can do it from notebooks running in HopsWorks, or you can do it from SageMaker or Databricks as well. So, you know, if I look at, I had a Databricks instance open here, so you can do pretty much the same thing that I showed earlier. You can connect to your cluster in your HopSearch cluster, and you can then do feature engineering and create feature groups and register your features. So that kind of gives you a feel for what you can do with the feature store and how you can use it. And at this point, I think I'm out of time. We're going to keep the talks to 25 minutes. So if there are any questions, I think we'll go to there. Before we go to questions, I'll just pull up this slide. So it is an open source project. It's available on GitHub. You can look at it there. We're on. You can start even if you want, and we're on Twitter, of course. We have a bunch of blogs around feature stores. So hopefully they'll be a useful resource for people new to the area. I see there's 1 or 2 questions. So the first one is, how does this compare with AWS SageMaker feature store? That's a very good question. So SageMaker released a feature store, I think it was last week, or was it the week before? And well, firstly, our feature store has been around quite a while. So we've had it for, I guess, you know, maybe 2 years. We just nearly 2 years ago released the first version. I had a look at their feature store, and I had a look at re-implementing some of their code. I mean, we'll probably write a blog about it at some stage. But I mean, the high level version I get is that their feature store is really layers on top of S3 and Athena used for their offline feature store. So not a huge amount of metadata. So things like tagging and you know, being able to support going from dev to staging to production with security, I don't think they haven't come that far. And the APIs are primarily SQL APIs, as far as I remember, and we're doing Python APIs. So there's quite a few differences in them. I mean, the best I can say is have a look at it yourself and see what you think. Our platform runs anywhere as well. That's the other point. If you're not on SageMaker, well, you know, you can use our platform. You can install it on-prem. We have AWS, Azure, and you can install it on GCP as well. You know, I think it's great that they've released a feature store. It shows you that the problem exists, and Amazon are very customer driven. So if their customers are shouting after a feature store, then there's a need that's out there. So we have another question, and this is not anonymous this time. It's from Vyacheslav Kladunsky, and it's, what is the latency of feature serving in HopsWorks FS, which is the feature store? So we built our feature store in a database called NDB, Network Database. And Mika Ronström is the inventor of that database. He works for us, I mentioned earlier. And when you turn on your phone, I think about 50% of the phones in the world use NDB as the home location registry database. It's a very, very low latency. in-memory database. So if you look at the internals of it, it's quite similar to Redis, except that it's a proper database with transactions. It's distributed, it's highly available, so you can get 5 nines availability on it. You can replicate it not just across availability zones in the cloud, but you can even replicate it across regions. So regions will be done asynchronously, but within an availability zone, you can do it synchronously. So the latency you get for reads is very similar to Redis. So you're talking, millisecond latency for primary key lookups. And in our case, when we do, if you create a training data set out of multiple feature groups, well, what you end up doing is a batch primary key lookup for the rows of the different feature groups, and then they're joined together to create the feature vector. So, even for 2 or 3 or 4 or 5 feature groups, it's still a couple of milliseconds to retrieve those rows, and then off you go. So, and the same as for writing, it's very high throughput for writing. So Mikkel has a blog called Mikkel Ronstrom. If you Google it, you'll see there's some entries about how to scale the database to 200 million transactions per second. I'm not joking, it's true, 200 million. But they're kind of extreme cases. So next one, Till Durman. Hi, Jim, thanks for great talk. You mentioned you're using DQ for profiling. Well, we don't call it profiling, it's computing statistics, but yeah, that's great, that's correct. And did you also consider DQ for feature validation? Yes, we do use it for that as well. So we use it for everything. We actually have, in the next version, we'll have a declarative API for using, really for DQ, so that you can define data validation rules and statistics computation independent of feature groups, and then attach them to different feature groups. So basically reusing these data validation rules. So that's coming in the next version. Is all of this open source, and has a commercial offering different? Yeah, I mean, it's a great question. The HopSearch is completely functional, fully functional, available as open source. You can do everything that I showed here. The things that are not open source are integration with Active Directory, LDAP, OAuth 2, so that's single sign-on, and integration with Kubernetes. So that's not available open source. Speaking of, so next one, Ren Gianaldi. Speaking of feature group, the data scientist may not know which one is best to choose from similar multiple features. So you've aggregation at multiple different granularities or versions. I guess we can leverage some AutoML techniques like grid search to further automate feature selection from the feature store. Yeah, I mean, this is a very good question. How do you know if a feature is any good? And there's 2 parts. The data scientist should describe them, and you can create tags, and you can have a discussion around them, so that other data scientists who discover your features, we have global search for features. I didn't show that capability, that they're able to see what they're using for it. There are some people who look at automating feature engineering. So feature tools is a framework that kind of does some of that. So if that's something that you find interesting as an AutoML technique, then I would go for it. I find it kind of difficult to think about that, but maybe there's use cases where it's quite useful. C1 Young, do you have time travel for online features as well? No, we don't actually, because the online feature store is used to store the latest values of features. You don't store historical values of features in the online feature store, because the online feature store is there to serve features to apps. So what that means is that your application needs to make a prediction now. The features it needs are, how many times have you clicked on the website in the last 10 minutes? How many transactions have you performed with this website in the last month, last week? You just want the latest value. You don't want to go back in time. You go back in time because you need to create training data, typically. Are you planning GCP support soon? For the managed platform, not until later part of next year, I think. It's not really high priority for us right now. What's the difference between importing, joining a feature group, and you can still install on GCP today. What's the difference between importing, joining a feature group, and importing, joining a traditional data set source? Yeah, I mean, this is a really good question. There isn't a huge difference in the sense, these are Parquet data frames that we're joining together. Okay, and so what we, so if you want to do if you have very large volumes of data, then you do have to do some Spark tricks for merge sort joins as well to do it at high performance. So what we have in advance is we have the metadata about the features. We know the primary keys, we know the types of the columns, so we have a query planner that can kind of identify the common join keys for you most of the time. So sometimes you might need to override them yourself, but typically it'll work. So that makes it easier for you as a data scientist to not have to worry about the semantics of the join. Yeah, what's the roadmap look like? Yeah, I mean, I think next year for us, provenance is, for me, we do end-to-end machine learning. We don't just do the feature store. Feature store is a core part of what we do, but HopStorks as a platform does training of models. We have KF serving coming, and end-to-end provenance, being able to really go from a model all the way back to the features and how they're ingested, and back to the experiments and the notebooks that we use to train that. To us, that's really key. Okay, I think we're done for questions because I've been answering quite a few. Thanks a lot for all the questions. And at this stage, I think we have one last one quickly. Is feature freshness bound to the feature and testing pipeline speed? Well, I use the term speed, or is there additional lag when feature is available online? No, I mean, in our case, it's we call it the cadence. So how often you write to the feature store, that's basically how fresh they'll be. So if you have a streaming app that writes every 30 seconds or every minute, then that's your latency. Okay, we support a JDBC API for writing to the online feature store. Okay, so then I think at this stage, I'm finished for questions. Thanks for all the questions, it was great. And Davor Bonaci will present. Now, Davor, I'll just brief intro. Davor, I think I met Davor many years ago. He worked on Google and the data flow team. And so I was really excited when I heard he was working in this area, and they're doing great stuff based out of Seattle. Off you go, Davor.
Thank you, Jim. Everyone, welcome again to our first global feature store meetup. I'm glad you are here with us today, and hope you'll become a recurring member of this group, and that we'll get the chance to speak more in the coming months and years. In the spirit of building the community and helping you evaluate the best path forward for your organization, I'm going to focus on the why, on the philosophy, if you will, behind feature stores. Obviously, I don't have to tell you that this space is super hot. We've seen, I think, an announcement after an announcement from quite a few companies, and we'll see more come January. But with all that flurry of activity, unfortunately, comes a lot of misinformation, a lot of marketing speak. And if you take one thing away from my presentation today, I want you to remember how to think about feature stores, how to cut through the noise, how to cut through the marketing speak. That said, I don't want to overpromise here. This is a super short talk to kick off the meetup. So, I'm sorry if anybody gets disappointed. I won't go too much into solutions today. I do promise to talk, again soon, to talk next time about how to technically evaluate the feature store. What are the right questions to ask? All that next time. Today, just how to think about feature stores to cut through the noise. Before we get to it, let me take care of some logistics first. I'm a founder and CEO of Kaskada, an early stage company in Seattle. I do want to state, I think I want to say right from the start, we at Kaskada do not consider ourselves to be a feature store company. While others might or might not, I guess, label us in a particular way, and while the definition of a feature store may evolve over time, I don't like to label us as a particular component. We don't sell feature stores. Kaskada does, however, power production-grade feature engineering. We help companies realize value from machine learning in production. We help data teams work better together. We help teams deliver results from feature engineering, but we realize that the technology needed for that is wider than just a feature store. And for those of you on this meetup that are already working with us, I think you know what I'm talking about, that our focus is on results. Obviously, as Jim alluded to, before starting at Kaskada, I was at Google for quite a few years, leading the Apache Beam project and building the community. I came to Google in the very early days of Google Cloud and built systems like Cloud Dataflow, leading the Apache Beam project, and partnering with several companies across the world to build a truly global open source community. And while I think Beam was a great technology for its time, it did not deliver the true unification of data processing patterns we hoped it would. In this context, this specific machine learning context, it turns out that Beam, like, other general compute systems aren't the best fit for machine learning use cases. They fail to solve this problem completely. And unfortunately, like, some other systems like Spark, may have some challenges. And, at least that's true now. At least that's true without some improvements. And you cannot easily bolt something on them to make things just somehow work well. I make, a claim now. In this talk, you will see some glimpses of how existing systems don't really, generic systems don't really satisfy the requirements for feature engineering. I do promise I will, in the future, talk in detail how this is the case. And I promise to be very specific and pedantic. For now, in this talk, just glimpses of it. With that out of the way, I'll start with a marketing slide. Everybody's talking about feature stores these days. Everybody has some sort of a pitch along the lines of use the same features in training and production, consistent feature definitions, iterate quicker, etc. To be honest, the state of the world looks to me like, I want to do a feature store, you want to do a feature store, let's all do a feature store. If you go to featurestore.org, our website, you'll see more feature stores listed there than maybe you want to, maybe you care to know about. This might worry you, but part of our mission at featurestore.org is to help you better understand the space, how others have solved the problem, and equip you to make best decisions for you, for your company. And in the coming slides, I will start to give you a framework, how to think through the decisions, or how to think through the decision-making process ahead of you. So let's cut through all of that and get to the core of things. First, obviously, we should understand the problem we are trying to solve. Understanding the problem is, half of the solution. And so I want to start here is that the problem is not, I need a feature store. The problem is not, I need to query feature vectors. That all of that is marketing speak. That's putting a technical solution before evaluating your company's business problem. Your business leaders don't care if you have a feature store or not. What they care about is the quality of your models in production and their ROI. So don't fall prey to people telling what you need. First ask why. And I want to position the problem that really we are trying to solve as the gap between training and production, which is really a gap between people, between data science and data engineering, and the gap between the tools we use to get to success. The why, the problem is not, I need a feature store. It is about how data teams work together, including data scientists, data engineers, ML engineers. I know we have all of, represented on this meetup today. It is how we work together, each applying our own domain expertise and delivering results efficiently and predictably. And to deliver real business value, to be recognized for the great work we do every day, we have to work together across the team to build bridges, across data science, across data engineering, to build bridges with our peers. This is how we can actually succeed. And this is what a good feature store can provide. So this is what you should focus on. And that is what I will focus in the rest of this talk. So too often, however, the teams are fractured. These are the real quotes from real data scientists and real data engineers, which are true, very often. Data scientists say, and I'm sorry to say that, but data scientists say that data engineers always keep responding no to them. Not now, not yet, it can't be done. Data engineers, on the other hand, say, and again, I'm sorry to say that, is the data scientist writes crappy code that is nearly impossible to productionize. And I know that these statements sound harsh, but this is what people have told us. This is what we've seen time and time again. I know that it may not be what we want to hear, but do ask yourself, please ask yourself, Regardless whether you are a data scientist, data engineer, machine learning engineer, how often you've said, heard, or thought about this story in your day-to-day job. And so unfortunately, with our fractured teams, with each in their own siloed tools, we end up with a long and rocky road to production. Here, I want everybody to think organizationally beyond any particular role that you may have. Like, think as a higher level organizational leader. If you think as a leader focused on results, and you see the current process to get to production, you'll see a mess. You will see some sort of ping-ponging between data science and data engineering. Sure, typically you start with data. Then we need some ETL export from a data warehouse on which data science can be done. Then comes some Jupyter notebooks. Then, the really difficult part, all kinds of negotiation between data science and data engineering, what can and cannot be done. That's the key part. That negotiation is a problem. Eventually, after a lot of back and forth, a lot of time, a lot of trade-offs, something would run in production. Typically, however, and ask yourself whether this is true for you or not, but typically, nobody is super happy. The model running in production is not the best model it could be, because so many trade-offs have been made to get there. So many features were not built that, data scientists think would actually improve the model performance. And maybe, your pattern isn't necessarily trading off between data science and data engineering in every case. Maybe you've built some self-service components. That's great. But you are still going to have some level of ping-ponging between tools and systems that don't always place nice together. And it still takes more time than it should to get from training to production. This is the real problem. My friend Jesse literally wrote a book on this. It's called Data Teams. You should check it out. And the blog post that we did on our website is covering this topic. It's one of the most quoted of our articles. This is truly an issue. And I want to end this slide in a similar way as the previous two. This friction, this is the problem. We need to build bridges. We do not succeed alone. We succeed as a part of the team, right? And that is where feature stores come in play. All right, so to summarize the problems, the real problems impacting our results are as follows. There is redundant work, like rewriting code between Jupyter notebooks and production systems. There are inconsistent results because of different feature definitions. There is a huge drain on time and talent when data teams spend most of their time communicating, synchronizing, negotiating what's possible, debugging the separate code bases, instead of using their time to solve their respective problems. So ask yourself, how much time went to this for you in this quarter? And so all of that results in slowed innovation and ability to deliver results after many months of hard work. And these are the real problems, and they get worse with scale. And if we solve this problem, I think we have a good chance of achieving real value. Real, true value. So how do we solve this problem? So I start with philosophy. Feature store can help here, can help a lot. But the right feature store, and the right feature store is a key part of the solution, but it truly needs to sit right in the middle between data science and data engineering. Right, and I'm going to say something kind of important now. Data science needs to be empowered to craft features, but not features in a notebook that will be tossed away, that somebody will say no to, that somebody will say that they cannot be implemented. Data science needs to be empowered to craft production-grade features and populate the feature store. Data engineering needs to be empowered to take it from there, to use it in production, to operationalize it, to operate it, to realize the value in production. This is key. I realize this is different. It may even be somewhat controversial, but most of the time you'll hear the data engineering should be populating the feature store. But I say, if this is, not the case, if data scientists are not populating your feature store or aren't able to, then this just isn't solving anything really. It's just pushing the problem from one tool to another. It's kind of just a wrapper. It's just a lateral move, right? Sometimes you'll even hear the data scientists should be populating the feature store, but when you actually talk to them, you may discover the data science team doesn't want to or is not equipped to populate it with the technology in question. And again, I say, if data scientists aren't populating the feature store or aren't able to, this type of feature store isn't solving anything really. It's just a lateral move, it's just a wrapper over something. It's not really solving the fundamental problem. So when you look at it, it's really that simple. Feature store is an API between teams. Data science team populates it, data engineering team uses it. And when it's done this way, it actually solves the problem. It is not just a piece of technology for the sake of technology. It delivers results. And that's what kind of I am, all about. And so coming back to thinking organizationally, beyond specific roles, we need to cut those dependencies. We need to cut the ping pong. We need to cut through the negotiation of what can and cannot be done. And that is the key part. Why feature stores need to span data science and data engineering. And when done right, all that clutter is gone. You see kind of a slide like this. You are now working together, smarter with better tools. You can work efficiently and deliver results and be recognized for the great work you do every day. That is kind of what we think about. So now, with that out of the way, how do you choose the right feature store? Here are some criteria to get you started. So this is building upon Jim's presentation earlier. Like, a feature store needs to do 3 things well, right? It really needs to focus on these 3 things to solve the problem as I just laid it out. It needs to deliver predictions in production with quality, right? That's what, in the previous presentation was called the online feature store, right? So how to deliver predictions in production with quality, how to get feature vectors and predictions out of the feature store. Second thing, it needs to be able to compute training data sets with completeness, right? This is what in previous presentation was called, quite nicely, an offline feature store, right? So here we need different things, but I want to add one more thing, which I think is key. Make adding new features to both environments easy. Right? You need production use case, you need training use case, but on top of it all, you need to build a bridge between the teams, and you need to make it easy for those things to happen from a data engineering side and from a data science side. Now, this may not sound that hard. It may sound easy, but I think it's damn hard. The thing is, each of these things is easy to do alone, but they are hard to achieve at the same time. Right? That's the thing, right? There are many systems people have built, many databases. There are many compute systems, right? They can do a lot of things. They can do all of these things, but they can do it alone. What they cannot do, and there's no standalone, off-the-shelf system, whatever it is, that can do this all of the same time, that is, that you can just take off the shelf and do something with it, right? The key part is not this cannot be done. The key part is it cannot be done well at the same time. There are too many things here in contradiction, too many things are a trade-off, and that's what makes it really hard to do. So I only have a short slot today, so I'll save digging into the technical evaluation, the pros and cons, for another occasion. I promise to talk real soon how to recognize a good feature store, how to evaluate a feature store. I have a very simple system of 6 questions to help you evaluate your options. But I think it's super nice, super cool, but that next time. So please, please tune in. Coming back to Kaskada for a second, Kaskada is obviously working on some of the ideas, we presented here. We are delivering an end-to-end platform for feature engineering, for feature serving, which has a lot more components than just a feature store. It brings in data science to the picture. That's a key difference. It can help, data scientists, I guess, design and visualize features. It can be tracked and approved. It is designed to solve the pain points data teams have and deliver value, right? That's fundamentally what we are all about. And honestly, you can try all these ideas yourself, and you can do it now. So for the data scientists among you, I would like to invite you to try the Kaskada Feature Engineering Studio. It's super simple. No setup, no charge, totally free, no credit card required. You can kind of sign up, open a website, and you can do feature engineering right from the browser. The only restrictions in this edition, you will not be able to load your own data. And we will provide, sample data sets for you. But you'll be able to do cool and relevant models. You'll be able to populate a feature store. You'll be able to try all of these ideas, how it would actually work, that you can share with your friends, that you can share with wider community. All that we ask is your feedback, no charge of any kind. So if you're interested, please sign up, and we'll work on, I guess, getting you access. The access is limited for now. We have way too much interest, and we are giving this service for free. So kind of, it is, there is this compute cost involved. So, please reach out and we'll try to make something happen. If you're a data engineer, we can do a quick proof of concept together. You won't need to change anything. You won't need to integrate with anything. Super simple. If you share some of your own data with us, we'll set up the platform for you. We'll work through any of the security considerations. We'll even run inside your environment if needed. So really not much needed on your side, and you can play with this technology, and you can do it today. Again, if this, the interest exceeds our ability to service people right now, so please reach out and we'll try to make things happen as soon as possible. All right, and I want to end with a thank you. Thank you for all of you for being a part of our very first global meetup. I know I am thankful for privilege of being able to co-host this meetup as well as present this content. Most importantly, I want to give credit to my entire Kaskada team. The ideas presented here are not mine alone. They're the work of each one of us working together as a Kaskada team. I would not be able to do this without hard work and dedication that each and every one of them puts in every day. So they are the one deserving the most credit here. I hope I achieved what I sent to achieve, to kind of challenge you to think about what the real problems are, not think in terms of technology. And so I will end here and maybe open for some questions. I do realize we are over time. All right.
There's a question in the chat, Davor.
All right, I'm trying to find it. Give me a second. Stefan says, thanks for this. Was useful to confirm some thoughts I have been thinking about. Otherwise, not a question, but a comment. At Stitch Fix, we enable data science to take things all the way. So there is no data engineering translation. See, happy to chat about implications of this approach. Yeah, so I do agree with this. And I know I know quite a few folks at Stitch Fix. We have chatted about this, I think, last time at Strata, when it was last time in San Francisco, with some of the folks at Stitch Fix. And I think this is a great idea. And so, Stefan, if you want to present a kind of Stitch Fix approach and things like that, I would like to invite you to come, on a future meetup and share it with us. But I think, though, that's a key part. A good feature store builds the bridge between data science and data engineering. And if it doesn't do that, it doesn't do, it is not solving the problem. It's just a lateral move. And so, I do think you are absolutely right. Jim, do we have more questions?
Sorry, I was on mute. I haven't seen any. Natalia, have anything else? I mean,
No,
I don't see.
I think we're good in questions. We answered them all.
So I guess if anyone else has general questions about the meetup, we can take them now. And if there's not, we'll take a pause. We do, just a reminder that the next meetup will happen probably in early January at some stage, and we'll have a speaker from Uber talking about Michelangelo, which is great. It's the original feature store. I think most people realize that the first, I guess, high publicity feature store that anybody talked about was Michelangelo in September 2017, I believe. It's quite a while back. Okay, we have a comment here from Ben Moran. Thanks, folks. Great start. Format worked really nice. Thanks very much, Ben. Appreciate the compliment. Then we have from Charna Parky. Is there a version of the meetup where the attendees can meet each other with cameras on? I'm not the expert. I don't know. Do you know, Davor and Natalia?
Yeah, I think this can be done. Obviously, we are in the remote world, and so I think we can continue doing the global meetup in this way. We have lots of plans for the future. It includes, any in-person events and things like that. But I think we can definitely do, especially kind of a Q&A session and open it for everybody to kind of share various things and, for us to interact more kind of in a face-to-face way. I think it can totally be done, and I think we can do it next time.
Yeah, I think. So Monty, sorry, Monty's on the call. Monty Slavin. So yeah, we have obviously not just Uber. We have, of course, at the next talk we have Monty Swaben's going to give a talk about Splice Machine, and their feature store is very interesting because they've actually unified the online and offline in one database. That's that. Okay. There is a reminder there in the chat as well to submit a talk at the link featurestore.org/submit-a-talk. You'll find it at the meetup page. And tell your friends, right? If your friends like feature stores and would like to participate, spread the word. We'd like to build a community here, and we're very inclusive, as we've mentioned before. And if you'd like to organize an event, you have a theme and something, just reach out, and I'm sure we can organize something.
Yeah. So kind of our values are, to be neutral and to be a safe space to discuss these ideas.
We have a talk. Would be great to hear from Tech on the future talk. I'm sure we'll hear from them. So there was news this week or last week, was it, that they've raised 60 million in total. So that's a big bet on the future of feature stores. And we've seen bets also by AWS SageMaker that this is going to be a big space. And as Davor alluded to, there'll probably be more announcements in the near future.
Somebody says, hi, great talks, thank you. I'm curious if you have any thoughts on dealing with time shift for low latency features. Do approaches like the commit log tend to scale to that? For example, say when pulling training data for a click prediction model and you want some prices as it was at the time of the click. So probably Jim and I may answer this question slightly differently, but the right feature store solves this problem fully, right? And so what you say here, like when you want price to be at the time of the click, that is the most important part that I would think about in evaluating a feature store. That's kind of that ability to evaluate the feature value at every time, right? So is the system flexible enough to give you an answer? What is the feature value at any given time? And you will see that lots of people are calling lots of things a feature store, but you will see very, very clearly that when you ask that question, that many of them will fail to be able to deliver a feature value at any point in time. So kind of, please stay tuned. I will talk about this and why. Like you heard me say that, systems off the shelf cannot do this. Yes, this is the reason why they cannot. This is why you will not be able to do something, take some, Spark, take some database, hack it together. It will not work. It will not solve this problem. And that's why it's going to end up being just a lateral move. That's why, we have this meetup to actually talk about hard problems like the one you talk about. What you're talking about is cross-feature lookup for a slice of time. And you will figure out that many feature stores cannot do that. The right feature store, however, it can, to the degree that fully solves this problem. Jim?
Yeah, I'll try and answer it. So I mean, partly it's relating to the hoodie commit time, which is processing time. So when you're writing out your data, you're writing the values at that particular processing time. Now, I'll just give you an example of where that breaks down. So you do need event time as well. So imagine you have you have an event, maybe let's say it's a horse race, and you have then the features of the values at that moment in time you write them. But at a later stage, there's an update comes in. Actually, there were some different values that weren't exactly correct at that moment in time, but you made predictions at that moment in time. So you have to decide then, okay, what was the correct feature value? Should I use the one that was at processing time or event time? Ultimately, you will need event time to do point in time joins. You do need event time, but that's for another day's discussion. There are many technical challenges here.
So event time is super important, and this is with people will break their teeth, unfortunately. And I will specifically talk about how to solve these problems in a truly real way.
Okay. Okay, so we have Monty has a point on that. Really good question. The temporal interpretation will be a big part. Okay, Monty's bigging him up for the next meetup. He's going to talk about this problem, which is great. So there are many technical issues that hopefully we'll address over the next few meetups, and there will be a technical focus as well. And really hope many of you can join us.
All right.
I think at that we'll wrap up, and thanks for joining. This was the first. There'll be a video. You can share the video. People who think it might have been interesting for them. And all the best. Have a great day.
Thank you so much. Thank you, Jim. It was a pleasure to co-host with you.
You too, Davor. All the best.
Bye.
All right. Bye, everyone. Have a great one.